Good evening to everyone present here. My name is Mohammed Azadullah Khan. I'll be taking through my internship project, which I have done under the guidance of Dr. Manas Sarkar. And this project is my project name is YouTube trend prediction, which I would be discussing by explaining the code, how it's working, the inflow line by line. So let's go to the code and understand how the code works. So in the starting, we are importing all the libraries, NumPy, Pandas, JSON, datetime. RE is for regular expression, NLTK for natural language processing, Seaborn, Matplotlib, all for data visualization purpose. And we have skitlearn. Skitlearn, it is used for building and evaluating predictive models. And I forgot to explain this. NumPy is numerical Python. It is mainly used for numerical and matrix operations. And Pandas is used for data manipulation, analysis, and handling data structure. This Pandas is built on top of NumPy itself. So let's start with this is importing. So first we are reading the CSV file and storing it in a variable called df. Df is data frame. Df, the thing the pandas we have imported, we are using it here. Df data frame is equal to pd dot read CSV. So this pd dot read CSV, it is a function in the pandas library to read the CSV file. So here as we can see, we are taking the data set and storing it in we are reading the data set and storing it in the variable df. Now df.head, what df.head does is df.head has a very simple function. It is used to view the first few records. Uh, the default value of n here is 5. We can change it as 2, 3, and anything more, like whatever we like. First few records. The default value of n here is 5. So we have not given anything means n is 5. So here you can see df.head. After it is like the CSV file is stored in df. Here df.head. So we can see 0, 1, 2, 3, 4. 4. We can see the first five records. It is named from 0. So 0 to 4. So variable analysis here in the data set we have used here is the US data set. This is obtained from Kaggle. So there are 16 columns named as video ID, title, published at, channel ID, channel title, category, trending date, tags, tag, view count, likes, dislikes, and so on. So these are the what and all we have. I have just noted down. So video ID, it has alphabet and numbers. Trending date, it has the date when the video started trending. So df.info. Here we are df.info. What it does is it is simple. It is used to obtain the information about the data frame information. See, it has how many columns? It has 16 video ID starting from 0 till 15. This is what it has 16 columns. Here it's saying the same thing. And it is telling the how many we have. It is a type is object. Here it is int for view count and for likes, for dislikes. It gives the information about the data frame. Here df.drop we are using. Df.drop is nothing but it is a method in pandas used to remove rows or columns from the data frame. So here we are seeing that video ID and thumbnail link. We don't need these. So what we are doing is we are dropping those columns. See, as I had explained in the starting, df.head n is equal to 5 default, but here we are passing it to, so we can see the first two in the first two rows we can see first two records we have obtained well, because n is equal to 2. If we give just df.head, it will give the first 5 frames as n is equal to 5. So let's go on to the next code. Next is category ID mapping. Uh, here we are using uh, here we are using the zip function. As you can see here, zip function and converting it into a dictionary. We are assigning every category ID. So here you can see ID to category. So one is assigned to film and animation, so that we'll have a clear picture like how many categories we have, different categories. The first is the film and animation, then we have the autos, vehicle, music, music, pets and animals, sport, short movies, etc. So we have total of 44, I think. We have total of 44 categories. Here we are seeing the keys. As it is a dictionary we know that it is a key value pair. So we are assigning with key value pairs. So the keys are 1 to 44. Here we are displaying the keys. Again, we are df.head and we are seeing the first two records in the data frame. And here we are using a lambda function, and we are category id dot apply lambda id to category. This is same. We are applying the same category id. We are using lambda function, and we are using that what we have created id to category. We are using it here. So whatever the categories they have assigned, so it will be used. Next, we are using data in, data instancing both the trending and the published day trending date, the trending date which is there, and the published at. They both have different date formats. One, the trending date has only the date, but the published at it has the time as well as the date. So we are making it into a single format. Here we are creating the function df.clean trending date. Here we are converting the date into a single format for both. So for trending date, year, month, date, we are making it as like that. And for the same published that also, here published that we are having time also, but we are making it as only year, month, date. So here we'll be checking it. See here, uh, here we have see a year, month, date. Here also we have year, month, date, and so on. Like that. That is done to have a common data type. Their trending day, trending date, as well as published date must have the both must have the both date format. Remember, we have imported date time in the starting for this itself. We have imported that. Here df dot clean tag. Here we are now we are cleaning the tags column by separating the tags into a list instead of one long string. So what it does is it is wherever we have it. So here we are making it as the tags which are having a like which are here we are removing the double quotes and we are removing double quotes and placing in single quotes, and we are splitting wherever we have the slash. Now let's go to tags. Okay, here we are applying clean. Here what the function we have written. Here we are applying the same, and here you can see it is turned into a here actually we are making that df dot uh, here when we are applying this clean tags. Here what is done here we have written return list, so it is converting into a list, and everything it is wherever we have this wherever we have what we say this separator, this there it's getting separated, and here instead of everything is getting converted into a list. So before you can see how it was like this. uh, Before prank we have the separator, what we call it as, I don't remember exactly what it is called now. But this by using this separator, we are splitting and converting it into a list. So here you can see here we obtained the list for this pranks, basketball, skits, ghost, funny, something, and all you have. So now natural language processing. Remember we had imported this import NLTK. NLTK. This is for the same. Here we are using that natural language processing. We have finished this tag splitting, like natural language processing. here we are using natural language processing for the title, and here we are clean titles. What does clean title do? Clean title converts uh, converts everything first into the lowercase, and then it is splitting into words. Then it is removing the unwanted tokens. It is removing the unwanted tokens, that is dollar for IN tokens. So like it is removing the unwanted tokens, that is starting with dollar, purely numeric tokens, non-alphanumeric tokens, stop words, something like the is, that we are removing. So NLP, we are using stop words and we are removing these, and after everything, we are joining all the remaining words into a clean string. Here you can see everything we are joining it back, return return dot join, everything we are joining. So what this function, what clean titles, what it is doing, it is converting first into lowercase, then it is removing the unwanted tokens, such as dollars, is numeric, is alphanumeric, and then after removing, then it is the non after that, the stop words also are being removed, and we are joining it. So this is what the natural language processing is being used for. Then after that, here we come to data. After that, we are checking the result. df.header is equal to true. First two we are saying. So data visualization. Here we are using many data visualization we have used. But the first we have used is a heat map. Heat map. First we are selecting all the numerical columns. We are making a list. The variable of the list name is numerical columns. So we have view count, likes, dislikes, and comment. As we had seen in the starting, df.info had given m64. So these are all numerical values. These numerical values are here we are calculating the correlation matrix. Correlation here, Seaborn, import Seaborn module we have used, right? So that we are using for creating the heat map. So here, what we are doing in the starting, um, here figure size is 10, 10, 6. What is 10, 6 is doing is, it sets up a 10 into 6 inches figure for the heat map. 10 into 6. So this is 10 into 6. Here you can see the heat map. Here we are seeing the correlation. Heat map, basically it gives the correlation between 1 and 0. So maximum is 1 and the minimum is 0. The correlation between view count and comment count is 0.58. Likes and comment count is 0.73, and so on. We have the maximum is 1. Here dislikes will get 1, comment count and comment count. Here we are seeing the heat map. We are using the heat map for visualization, like how much the correlation helps us to find. This is very important. Why? Because heat map help us to find the correlation between the different values. Here view count and comment count, how much is the correlation, we'll get to know. Here we are using that. Where is that CORR? Here, this correlation matrix is equal to DF numerical columns. Numerical columns are these dot CORR. CORR compute the correlation coefficient between the specified columns. Here, next we finish the heat map, and here what we are doing is, here we are counting the frequency of words in the video titles and identifying the 50 most frequent words that are being used by using the counter. From collections, we imported counter, collect from collections, import counter. This is the thing we are using. Here we are counting it. Here we are counting. Here, here here we are finding the occurrence. Sorry, here in the for loop we are finding the occurrence of words in the video title, and here we are finding the 50 most words in the title. So the most frequently used, like this is the main thing. Why? Because we, based on this frequently used words only, trending videos might go trending. So this is used. So next coming to like after this we have only the uh, data visualizations only. We have bar plots and different plots we have used. This here we are using the bar plot for finding the uh, relation between words and title and number of videos. See, for trailer, this may we have more than 8,000 videos. So for highlights, we have more than 8,000. Like it is more than 8,000. This is more than not 9,000 exactly. Less than 9,000. Here it is somewhat between 8,500 videos. So this is the we have occurrence of words in video titles. So this is the relation between number of videos and word title. After this, we have all the visualization like this on the bar plots. We have video categories, trending videos by categories. So what this bar plot represents is categories versus the number of videos. Entertainment we have more than 40,000. Sorry, here also I think so. It's 80,000 I guess. No, 8,000. It's correct. So here it is 40,000 of entertainment. If the category is entertainment, we have more than. So we are finding the relations. So here most of them are the data visualization, which have been which we are using Matplotlib and Seaborns for using that. So let's get into the main topic that is these are data analysis and results from here. Here also we have visualizations. More visualizations are there. Different plots are there. Like you can see here, different plots have been used, like dislike ratio. We'll go and we'll see the main products, that is the machine learning part and the data pre-processing and training the now fine and analysis. Here comes the main. Here, what we are doing is sort the data frames by view velocity in descending order. Here you can see a dot sort values. Here, if we use only dot sort values, it will be sorting in ascending order. Here, so we are making an ascending is equal to false and dot head 10. So here we are keeping as n is equal to 10. So here we will get the top 10 which videos which will like top 10 videos we are getting. We are sorting the by view velocity is the rate at which a video is getting likes or dislikes. So after that we are printing this, the top 10 trending potential videos are like this. We are printing this is nothing but printing for loop and printing it. So let's move on to the next part of the code. So here we are sorting the data frames by view velocity in descending order, and the top 10s are selected. And the same thing that what we did there, here where we are did the sorting in descending order and top, here we are displaying the 10 videos. And here we are creating a bar graph also. Bar graph here you can see uh, s- Stacky Bubble MB. So this is the most trending video. And what happens if you destroy a black hole is the next trending. So based on the view velocity 0, 1, 2, 3, 4, 5. It is given based on the view velocity. Now here next comes the data training. Here comes the before preparation and applying the suitable ML algorithm. So data pre-processing, this is the most important before we are splitting the data into the training and the what we call as test and train data. So that is what we before that we do the data pre-processing. What data pre-processing is handling the missing values and encoding the categorical variables and feature scaling, test train split, feature selection, and feature selection is that the select the relevant feature you'll be using for prediction. So only the which will be needing for the like which is the most relevant for the prediction. Only those columns will be adding in the feature set that will pass it to the explain. And now let's go to the code and see what happens. So this we are dropping the irrelevant df underscore c. This we are dropping these columns description and title. These are not required for the training purpose as these are not important. So here we are seeing a box plot of view. Here we are selecting a numerical features like how we had done in the earlier for the heat map. Here we are creating numerical features list, view count, likes, dislike, and comment count, and we are creating a box plot for each of them. See, box plot for view count, box plot for likes, box plot for dislikes, box plot for comment count. So this is the thing here. Important calculations here. What is engagement rate? Engagement rate, we are calculating the engagement rate, likes plus dislikes plus comment count divided by view count. So like dislike ratio, we are obtaining like dislike ratio, likes plus dislikes, likes divided by dislike. So likes divided by dislike gives the like dislike ratio. Comment view ratio, comment count divided by view count. So like dislike per comment, dislikes divided by comment count, and calculation for days since publication. Trending date. Trending date is we are using here PD pandas. Like we know that um, NumPy and like NumPy and pandas are used for numerical calculation. So that one we are using it. NumPy here we are using NumPy here we are using pandas. So we know that that is used for numerical calculations. So we are doing that. A trending date is trending date in the format of year, month, day. Remember we had converted the published at and the other started trending date, say day since publishing. So here we are calculating that by using the formulas. Uh, that is here comment per day is comment count divided by say days since publishing. We'll get per day how much they are getting. View velocity. This is the most important feature which we are using. No. Come back. View velocity. View velocity we are you view velocity is the rate. View velocity is a view count plus one divided by days since publishing. That is, it is the view velocity is the rate at which it is getting views. That's it. So then after that we are displaying the first two columns like we have done this. So you can see the all the columns which are title, publisher, channel ID, comment ratio, likes per dislike comment. These are we have calculated this. You can see like comments per day is this much for this video, and likes per day we have calculated likes divided by days since publishing. So we are adding all this by calculating this, and we have added these important columns for our data frame so that it will be easy for prediction. Why? Because view velocity is most important. Why? Because it is the rate at which uh, a video is getting likes, and dislike ratio, like ratio, these are also important, and the comment rate also plays an important role. So we are calculating whatever we are needing, and here we are checking if any new cell has null. Is NA, which checks if is null, if a new cell is null. So before we are training the like here we have used here in the for the training purpose, random forest regressor is the algorithm which we have used. Because it is the one, it is giving high accuracy, almost more than 98% is the accuracy. So we are filling missing values with medians. Here calculating the median of the dislike per comment column. Here we are filling the missing values with median, calculating the median comments per day column, and filling the missing values with median, calculating the median of the view velocity missing. Here basically this is the data pre-processing part we are doing. before applying our machine learning model. So print df dot is in we are again checking. This is I think I have repeated the code. My mistake. Sorry. Here we are applying the machine learning model. Machine learning model. Remember in the starting we had used the skit. From the skit is the library which we are using for uh, applying the machine learning model. So here you can see a random forest regressor. We are applying a machine random forest and random forest regressor we are applying. So here in the X-train, Y-train, first we are splitting the data into two variables, X-train and Y-train. Here what X-train contains is X-train contains the selected feature columns from the data frame, and Y-train contains the target variable, that is the view velocity, the model that the model is that the model will that the mod see X-train will contain all these features. Features is what? All this features is the list: view count, like, dislike, comment count, engagement rate, like, dislike ratio, and so on. We have it is a list. Explain contains the selected feature, that is selected feature column from the data frame. So this is the features we are passing for the extrain. So Y train contains the target variable. Target variable is the view velocity, which we are focused on. Why? Because more the view velocity, more is the likeliness of the trending. So after here we are initialize the train for random forest regressor model random forest regressor n estimator is equal to 132, random state is equal to 0. Here we are model dot fit x train comma y train. Here we are training the model. Here after the after we are training the model, here y test here we are test the data view velocity. Next will be evaluating our model based on the training. Here will be check for infinite values in x train. This is like it we are checking if there are infinite values in X train. We actually don't have, I think so. We don't have, and checking for very large values if it is greater than 1 E10. So if it is greater, very large values, if we are checking if any column is having very large values or any having infinite values, and we are let's see the accuracy based on our own data set. So here we are doing the calculations. We are calculating the mean squared error MSE, y test minus y test comma y predicted. We are calculating the mean squared error. That is the actual versus the predicted one. So and we are calculating the root mean square. Here we are using the NumPy's model, NPy library, np.sqrt. It is used for mathematical calculation and matrix operations, right? NP. So we are calculating the root mean square error and MAE mean absolute error and calculating the variance score. These all are important because the variance score, and these are very important to see which machine learning models are giving the more accuracy. This is what going to predict our accuracy. So after seeing this, after calculating the variance, we are seeing a plot of y test y test and y predicted. So let's see the residual plot. So here we are seeing like it is almost this is the actual values. This is the predicted. Some are going a bit low, some are going a bit high. So it is almost having the accuracy of. So here you can see variance score is 99.99. So percentage, if you do this is not in percentage. So if we do it in percentage, the high accuracy is coming 99.99 to 1. So mean absolute error is this much, root mean square error is this much, and we are doing the plot for the same. Then afterward, we are seeing the final. Let's see the final plot. This is the actual versus predicted. We have plotted this again using a red and black, red and blue, so that we'll see how the actual values uh, are aligned with the predicted values. How the predicted values align with the actual values. Here, this testing we are doing the testing for the on the test data set, checking for not not null values, and this is not that important. Like after the training is over, after the data set training is done, we just see the accuracy by the calculating of root mean square error and variance. These are very important, but because this is what that predicts the uh, what we say accuracy of the machine learning model. So here comes the last. Here we see the making predictions on the predicted data. So prediction is equal to model dot predict x pred. So here we are doing the prediction, and then we are seeing how it is how the actual values align with the how the predicted values align with the actual values. So here we'll see sort the prediction result. What is this is doing is sorting the sorting the prediction result by predicted view velocity in descending order. So here it is a visualization. So the top trending video will be Rihanna's. This is the predicted one. What we have predicted. Rihanna's full Apple Music Super Bowl. This one is going to trend the most future in the future. So this is what the after random forest first we are doing the data pre-processing. Actual comes from the data pre-processing, and after that is removing the null values this one, and applying the machine learning model random forest regressor, and splitting the data into testing and training model test train split. What we have done there, that is most important. And X train, Y train we did, then we predicted the value. Like actual, then here we are checking the predictions. Here we have combined the prediction with the video information, title, predicted data title, and then channel. Here we are doing the prediction results, and we are plotting the same for the same thing. We are predict after prediction, we are plotting the predicted view velocity for each. See, the view velocity which we kept in that y train, that we train the model for view velocity. Y train is the target variable. So this is the predicted one. Final prediction. This one was the most. I was telling the same actual versus predicted. Here you can see the actual. Here you can see the actual. Actual is the red line, and the predicted are the blue dots. So we had calculated before predicting on a data set, how we had predicted this. Let's see the code. Here we are using the scatter plot. Uh, what it does is scatter prediction results, actual view velocity versus the predicted view velocity. So the target variable view velocity is the main feature which we are using it as for prediction purpose. So overall, I would like to conclude by saying it has an accuracy of 99%. 99% accuracy is there. It has an accuracy of 99%, and this model, random forest regressor, which machine learning model we have used, is the most suited for this one. As we all know, this random forest is built upon random forest is the combination of decision trees. Decision tree, here we have the result of one. Decision tree gives one output. So here we have the combination of decision trees. Combination of decision, each decision tree gives a result based on the majority it gives. So random forest works on this principle only. It is a combination of decision tree, and the decision tree, each decision tree gives one result, and the based on the which have more, like which answer has the more percentage, that one will be predicted as the final. And this what is the scope of the project? I would like to conclude by saying the scope of the project. The scope of the project is, like, as we all know, as YouTube has become a brand for advertisement, people can use the prediction model to predict which videos would be nearly trending in the future, which would trend in the near future, and based upon that, they can advertise their advertisements. So that's all from my side. Thank you for listening to me. I have completed. I hope this is fine.